All right. There are a bunch of properties of limits. I'm going to try to do this very quickly. It is 11:40 at night, the day before I'm leaving for the Disney trip. So, I would like to get to sleep. However, education must continue. Here we go. If you have a constant, remember, constant is just a number. So if I just said to you x equals 7, no matter what, x always equals 7. So we're looking right now at what the limit is as x approaches 4 on the function 7. So if I were to look at a picture of a graph where where y is always equal to 7. So here's 7. No matter what, y is 7. So that's going to be a horizontal line like this. What is the limit as x approaches 1, 2, 3, 4? Well, from the left and from the right, it's approaching this point, which is 7. Let's do it for this one. The graph is y equals -5. What is the limit as x approaches 0? So here is x approaching 0 this way, approaching 0 this way. The value here is -5. So if it's a constant, just a number. So if I said, what is the limit of 23 as x approaches 700? It doesn't matter. No matter what, there's only one y value on the graph, and it's what the constant is. Okay? Number 2, we have the identity. Okay? Remember, the identity function is whatever x is, y is. So if I said x is 0, y is 0. X is 1, y is 1. X is 2, y is 2. Remember, it makes this diagonal line that goes just like this. So if you want to know what is the limit as x approaches 7. Okay, well, here's 7. 1, 2, let's just say 7's over here. If this is the identity function, what should the y value be if your x value is 7? It should be at 7. So again, if this is your graph, y equals x, what is going to be the limit as x approaches -pi? It's going to be -pi. Only for the identity function. It cannot have anything else with it. So for example, if I said, what is the limit of x as x approaches 253? The answer would be 253. Okay? So far, we know what the limit of a constant is. It's the constant. The limit of the identity is the limit. Okay? If you want to find the limit of a sum, you can very easily just separate it to be the limit of x as x approaches 5 plus the limit of 7 as x approaches 5. So now here's the two rules. This is the identity function. The limit of the identity is the limit. So I'm going to take the number 5 and I'm just going to put it over here. Plus, I want the limit of a constant. So it has to be the constant. And then 5 plus 7 equals 12. Okay? You also could graph this if you really wanted to. Just for a visual, the y-intercept would be 7. The slope would be +1. And so it makes sense that as you approach 5, your y value is 12 because 5 plus 7 is 12. You don't need to graph it. I'm just showing you the visual. Do this one the same way. You're going to break this up. What is the limit as x approaches -4 of x? And what is the limit of 9 as x approaches -4. So when it's the identity, it's the limit. When it's a constant, it's the constant. -4 plus 9 is 5. Try the next one. I'm not going to walk you through it, I'll just show you the work. Okay, for the differences, it's going to be the same thing. So you're going to do the limit of 12 as x approaches 5 minus the limit of x as x approaches 5. The limit of a constant is the constant. The limit of the identity is the limit. 12 now minus 5 is 7. Do it again. The limit of 19 as x approaches 14 minus the limit of x as x approaches 14. The limit is constant. The limit is the limit. 19 minus 14 is 5. Okay? Same thing. Now we're going to be multiplying the limit, very redundant, as of -6 as x approaches 5 times the limit of x as x approaches 5. The limit is constant, the limit is the limit. -6 times 5 is -30. Last one, the limit as x approaches 7 of -10 times the limit of x as x approaches 7. Constant, limit. -10 times 7 is -70. Okay, I'm just going to keep going. Okay, now, this is going to be a little bit different. So we're going to put this all together here. So in this problem, you have a difference, but if you look in the difference, you have a product. Okay, so we are going to rewrite this as the limit of 7x as x approaches -3 minus the limit of -4 as x approaches -3. Okay, then we're going to break it apart again. The limit of 7 as x approaches -3 times the limit of x as x approaches -3. That's all coming from here. Then I'm going to take the subtraction here. I'm just going to do that separately. So let me do these first. The limit of a constant is the constant. The limit of the identity is the limit. 7 times -3 is -21. This is a limit of a constant. It's the constant. So -4, -21 minus 4 more is -25. Okay, same thing. Thinking a little bit outside the box here. This is 6 times x squared, but x squared is x times x. So it's going to be the limit of 6 as x approaches 5 times the limit of x as x approaches 5 times the limit of x as x approaches 5. That's because these two here are going to make x squared. The limit of a constant is the constant. The limit of the identity is the limit, times 5 times 5. 6 times 5 is 30, times 5 is 150. Okay, go ahead and try the last two. Again, I'm just going to work them out. I'm not really going to talk about them, but here's the work. So no, I have to go back here. It's the limit. You're already subtracting the limit. It's not at -7. It's just at 7. You're subtracting it here. So minus. This stays positive. So this should have been +7. So it should be minus +7. So it should be, this should be 8. Okay, I'm going to stop this video here, work on the worksheet that's underneath here, and then tomorrow you guys can come back and do the limit of monomials, polynomials, powers. We're going to do all that stuff tomorrow.